So welcome to lecture 24 of MCS 507, a course on mathematical, statistical, and scientific software. So this is a little bit an unusual topic for um, mathematical lecture. So this is on web scraping, essentially. Unusual or not, but this features in a week on data processing. And one way to retrieve data is via crawling the web. Um, so we will see how to use Python to visit web pages. Um, why is that useful? Well, um, so we have already seen that we had our my server script of one of the earlier lectures that we could forget about having to do with a particular web server so we could practice. Um, we could also browse the web using the scripts. In some sense, this is a lot more efficient. It allows us to bypass the clicking, pointing, and clicking. We could steer the navigation into our interests. So look for the URLs that we want to visit, look for the information that is available on the website. And at the end of the lecture, we will see how we can build a very elementary web crawler. So we will recursively visit web pages. Um, okay, so here is a first illustration, or if you like, application. I just executed the script earlier today, so if you want to request the weather forecast from within a terminal window, see here in the Windows PowerShell, we can get the weekly weather forecast. So for this week in Chicago, so you can see that this is March, but tomorrow it may be snowing, or tomorrow for me, but when this lecture actually happens, it's Monday. So snow is possible. So the point of this is that what the script does, it opens the website here. So this is a data site from the National Oceanic and Atmospheric Weather Service. Probably scramble the NOAA name now. But this is the National Weather Service, so this is where NWS stands for. So there's a lot of data available for free, and that you can retrieve. So one can make an entire database of weather forecasts for the entire country, for all the states that are available. So here you see that I went to the state of Illinois and I went to a specific location. Okay, so here we will use the URL lib. We will, from the module request from that package URL lib, we will import the URL open function. So that will open web page. So here I have splitted it off in the host and then the rest of the URL. So you can see that one can make this, one can, if you like, you can fill up an entire database by doing this systematically, state by state. Here I was only interested in the Chicago region. So here you see that I'm going through the data file. So, and what the web scraping essentially does, so it allows to treat a web page just like another file. So we will read this web page essentially line by line. So I know what this web page looks like. So it's a text base. So in some sense, in preparing for this code, you actually go to this web page and you look for the structure. So I was looking for the letters, the forecast, and then also for the location Chicago. So once I see Chicago in the line, then I will read two more extra lines. So here too, when I see this FCST in the line, I will read one extra line and then the line will be printed. So the read line is not essentially given as a text string, so it's kind of in a byte format, and one needs to decode it. So in the very earlier versions of Python 2, the read line just gave you text strings. Now one needs to apply the decode method to the output of read line. But otherwise, it is very similar. I'm reading the line essentially, and I'm building a string. So the line here is actually a sequence of lines that is printed with the information that I want. That is the weather forecast in Chicago. Okay, so the URL open is interesting. So one can immediately retrieve an entire web page. So here one can retrieve the page that is at the home page, the main page for the Python language, with URL retrieve. What that will do is this will make a local copy of the HTML file that is available at that location. So we can, so there are alternatives here. So we have on the previous slide, I gave an illustration of the URL open. So this allows to browse, to parse, to go through the page line by line. One can alternatively retrieve the entire web page and then process this just like a file. Exception handlers are important, so it may be that things are not available, so then you do not want that your program crashes. So here is an example of how to protect you from this crash. So the command that can trigger the exception, the URL open, that command is surrounded by the try block, and the try handles essentially any exception. So anything that could go wrong, inclusively some network error, will actually generate the message. And it will return. Otherwise, the web page will be copied. Here you see that we copy the web page 80, reading essentially now 80 characters in each step. So this is an alternative copy from, if you do not wish to use the URL retrieve, then you can read the data on the page with the number of characters. So there is the read line, but there is also the read with the number of characters that you would want to read. So the number of bytes essentially. Okay, so here is an application. So if you want to fill up a database, so we have seen already that one can use Python scripts with PyMySQL. One can fill up a database. A nice application is to download the data from the web and then fill up your database. So if you now are interested in the weather forecasts for the entire country, for all states, one can do this with the adjustment um, of the forecast and fill up a database like that. So here, as an illustration, I mention an application of a database of archival course offerings at UIC. So that data appears already in a structured format on web pages. So what you need to do is you need to go to the main page and study the formatting, and then extract the formatted data, parse the formatted data into data tuples that can be inserted in a database. Okay, so here is an example. So I took Latin because there are not too many Latin courses that are offered, so it fits on one slide. So the script will prompt for a subject, a year, and then a semester, fall, spring, summer. And I was using the codes that are then used from that web page. So the structures of the web pages are generated, essentially are actually, these are static pages, but they follow a very nice recipe. So all start with class schedule, then there is the year followed by spring, fall, or summer, and then there is the subject. There is one problem with this. So I had to run this. So this lecture was prepared a long time ago, and the scripts are still valid if you run this with version 3.5 of Python. So later versions of Python complain about the certificate of the web page of the Office of Student System Services. So there are ways around this, but since this is an ad hoc illustration, I decided to skip it. So, nevertheless, so it remains a valid example. So here, the online data that gets retrieved from a web page that somehow has this hierarchy of the study of the data. Okay, so let's leave that application for now. So one can parse HTML files just as they are regular text files, and that is a very nice topic to learn about HTML code. It's also a very nice illustration on how to process text. Now, Python provides parser modules, and these are modules that are actually aware of the structure of HTML pages. So that relieves you as a programmer, that relieves you from scanning for specific tags. So the HTML parser is a class that can be imported comes in with Python standard. So you make your own instance of the class, overriding the handlers that you need. So in some sense, this is another illustration of application of the object-oriented programming. So we make our HTML parser class, and we define how we are going to whatever going to happen with the beginning of a tag and what happens with the end of a tag. So, and we will feed this class the data 80 bytes per step. So what this class essentially does is that we feed it 80 bytes each time when we call the feed method. And depending on whether there is a tag or not, the handlers will be called. So here is a first illustration. So the scripts that I'm now trying to explain are working towards the web crawler. So first application that you would want to do is that for any tag you want to see what are the types of tags that are used. So the most common tag in a web crawler is that you want to get the anchor tags, to which sites are the um, to which other sites is the current web page referring to. So that's an anchor tag. So there are also various formatting tags. So what every tag has, there are several attributes, but we are here mainly interested in the type of each tag. So we will build a dictionary. So at the start of each tag, we will initialize the dictionary with the count if the tag is not yet there. Otherwise, we will update the count. So it's a building of a regular frequency table. How does this work? Well, here is the structure of our tag tally, which is inheriting from the HTML parser, and we will override the handling of the end tag. And here are the documentation strings. What will we do with our tally? So we will make a frequency table of all the tags that are appearing on this website. So when we make a new tag tally, so we will initialize the dictionary. So the data attribute for this class is a dictionary, the frequency table with all the tags that are occurring on this website. Then we have the string method. If we print the string representation is a string representation of the dictionary. And each time when we encounter the end of a tag, we will update the dictionary. So these are the three methods that are defined. Then here is how we use it. So we open the website. So here I define everything with the UIC homepage. And this script will count how many tags of each type are occurring. So at the bottom of this page, you have the string representation that is called. Before the while true loop, we are making an instance of the tag tally class. So tags is an object that will store the dictionary. And we will feed to that class the content of the web page, 80 bytes per feed. So we stop the feeding when there is no more data. And the beauty of this HTML built-in handling of the tags is that we actually do not really need to worry about the scanning of the specific tags. So here are then the specifics. So we are overriding the constructor. We have to make an object. We have to initialize the HTML parser class, and we add an extra data attribute. So the extra data attribute is called tags. So that's initialized with an empty dictionary. So at the end, we essentially print the dictionary. So I make one very long string, and I make my own layout of the frequency table. So that is what the string representation does of this class. Okay, so then what's happening? So we have the application of a dictionary. So what every Python programmer knows, how do you make a frequency table with a dictionary? That's the standard application. And that is essentially applied also here. So whenever there is an end tag, so when there is an anchor that is closed, so here you don't really need to even know what is an anchor. So you will see when you run the script what are the possible anchors. The type of the anchor is returned, so in the tag. So we will go to our dictionary. So we check if the key, so the keys are the tags, if the specific tag is one of the keys in that dictionary, then we update the value. Otherwise, we initialize the dictionary with tag as the key, and we give the value 1. So that's it. So in a way, this is data processing, file processing, scanning through a text file, but the text file is HTML. Okay, so in our next step in building our web crawler, we will look for the uh, anchor tags. So these are the tags of type A, and we look for the anchor types that where we do have the HTTP in there. So these are the hypertext references. Now, in an earlier version of the code, if this is really a programming class, it's an excellent exercise to start scanning for these HTTP links, but note that there might be, if you look for double quotes, uh, there might be line breaks, and especially if you're reading with a buffer 80 bytes long, you will have to take into account that you may have opening quotes and closing quotes. This is an excellent programming exercise, but this is not really a programming class, so we are going for convenience and using this HTML parser class, which we actually now use for the HTML references. So what this class will do, it will now again we will inherit from the HTML parser class. We make a new HTML refs class. So and now at the end of every tag, we will look for the anchor attributes, and we will store the hypertext reference. So that is given in the attributes. So what we are now after. So think about a web crawler. So we are starting at a given web page, and we want to see from that web page what are all the other web pages that we can reach. So what we will maintain is not a dictionary anymore. We could, but now we have a list of all the links of all the websites that we that are contained in this HTML file. Okay, so we start again from the homepage of UIC, and we buffer with 80 bytes each time, and we have our class refs that will store all the hypertext links, and that will be printed at the end. So we use the same template as with the tag tally. We make an object, an instance of the HTML refs class, and we feed the data 80 bytes per time. Okay, So we initialize the list to the empty list when we make a new object of this class. Again, initializing also the HTML parser. Um, and then we print the uh, string representation of the list. So here, the result, I've made it so that instead of having one very long string, if this gets printed, then every link will appear at a separate line. Okay, so now comes the finding of the HTML references. So what happens is that all the attributes are given as lists of tuples. So from the website of the UIC, we find that the H references, the hypertext references, appear as the first type, and then the second type is the HTML that refers to. So what we are collecting is from all the attributes, we check whether the beginning of each tuple is this proper href type, and then we filter from that the second component. So we make a list of, we copy the tuples, and then from the tuples we drop the first component. And the last step is then an appending of two lists. Okay, most likely there will be duplicates in there. But this is the filtering. Another example of Python, the list processing and the manipulating of lists of tuples. Okay, so then this lecture goes efficiently. So let me go now to the final end. So this is the web crawling. In more general, I will give the reference for general web scraping. So what do? We are scanning the HTML files recursively. So each time when we open a web page, we will run the HTML reference list and get all the HTMLs there. We then, for all the URLs in the list, we open the web page. So you can now think of a graph, and we will do this recursively. This is an interesting application of the breadth first search of a graph. So now you can do breadth first or depth first. Depth first means how many levels down do you go. So of course the World Wide Web is extremely wide, so there needs to be limits on this. How deep will you go? So starting from your starting point, how far out will you go? So there is a tree that you will construct. Also, one has to be careful. You have to maintain a list or somewhere in order of all the web pages that you have visited. So you don't want to run into an infinite loop. So there are many things to consider. So I indicated already that you do not want to turn back, but also you have to remove the duplicates from the lists of the URLs that you collect. So exception handlers are extremely useful here. So some links will not work. Some websites do not like that to be visited by scripts. So in a way, this is finding a path in a maze. So here, the script that I'm presenting is very, very basic. but you could make your own search engine in this way. So you can search for a specific information and let your crawler go look for very specific data. Also, you can, with the information from the URLs, you can limit your searches to specific websites. I ran the web crawler at our starting from our UIC website, and it takes a while. So here the maximal depth was only 2. And it lists about 680 websites. So this was done with the latest version of Python. So that meant that that some web pages probably that didn't have the proper certification were not visited. Okay. So to conclude, or I will say something about how this web crawler works. So we have seen the ingredients with the HTML parser. So we need to figure out a way how to maintain the list of visited links. And we also need to run through this recursively. So we will have the list of links, and then we have the visited. So this is a filter that will, this function here, new location, gets a list of links and compares the list of links to the visited. So it will take to all the links and look to the locations. So we will visit every location only once. So often it happens that the same website is visited many times. What is here being used is the URL parsed. So when a URL comes up, at the very beginning with the weather forecast, I indicated that the complete URL is broken up into pieces. So with the URL parse, it will actually break up the URL into several parts. So the first part is the HTTP or HTTPS. Then the second part, and that's where we were using the one, is the name of the website. And then everything that comes, all the folders that are under that. So here we are mainly interested in the top websites. So we are interested only in the server locations. Okay, so we will crawl the web. So the main web page will ask for the depth. It will maintain, so this is a recursive function, it will maintain a list of visited locations. So one need to give here an empty list for all the visited locations. And it will return all the locations that, all the web locations that have been visited. Okay, so the parse is useful of a URL. The unparse is also very useful to reconstruct. So we will visit those locations then again and see how many pages that can be reached from there. Okay, so we keep the counter of the depth. So we go in one, so this is depth first still. So each time the counter k locates how many steps down the tree we can still take. So we are at current counter, and then we do the recursive call, we decrease the counter by 1. So I mentioned the searching of a path in a maze. This is the web version of this. So this is called exhaustive combinatorial search, also called backtracking. So this is a very useful problem-solving technique, but most likely brutal force. Okay, so what is now the next step? Here is a reference if you would be interested in this topic further. So there is the beautiful soup library that gives you more support for parsing HTML code. So this is a library that needs to be installed separately. So what we did today was mainly using the HTML parser. It's very well likely if you start going into that direction that you might get too limited of this, or you might start to implement things that have already been implemented before. So before you develop an entire big application, please consult this book. I will end with some exercises, suggestions for exercises. So we started at the UIC website. You could start to restrict your search in specific locations that are only in the educational domain. So see if that makes for a better search, if you can reach more locations like that, or most likely you will have fewer, but if you increase the depth, perhaps you will see a broader network of educational institutions that are somehow connected to each other. One can look for a path in a maze, so you can look if if two locations are connected to each other. One can browse from one website to the next website. The iterative version of the web crawler is actually interesting for certain types of applications. If you would want to provide more user control, so the iterative version would use a stack of already visited web pages. Suppose that you would want that there is some kind of monitoring happening, that as a user, when you launch this web crawler, somewhere you need to decide on the depth of the pages. How deep are you? Should you truncate a branch that turns out to be not so fruitful in your search? Okay, so this was kind of an odd lecture in a scientific software class. But in the end, so the origin of the World Wide Web and of HTML was of scientists interested in sharing data with each other. If there is some data site that lists important measurements, so here I mentioned the weather forecasts, one can have scripts that automatically are starting to use the most up-to-date information. So one can have data pulled in automatically when you run your scientific application. Okay, thank you for watching. So this is the first lecture in this course in the week on processing data.